Hello everyone and welcome to the Weekend Word. This week we'll be discussing additive manufacturing. For us, additive manufacturing is a term that encompasses a range of manufacturing processes that may include 3D printing, 3D knitting, liquid printing, and others. It is a manufacturing process made possible by our transition from analog to digital processes. Generally speaking, the concept of additive manufacturing, as the name implies, adds material to create an object. By comparison, traditional manufacturing methods are what are known as subtractive manufacturing, meaning that we're taking material away through milling, machining, carving, shaping, or other means. Additive manufacturing uses computer-aided design software, or CAD, or they use 3D object scanners to map and then deposit material layer by layer with a high degree of precision. One of the most recognizable and scaled businesses using 3D printing are that of invisible aligner companies, such as Invisalign, made by a company called Align, and 3M Clarity aligners, which I'm actually wearing right now. To achieve that perfect smile without the brace face, patients undergo digital scanning of their teeth. The scanner captures the detail of each tooth, and then the upper and lower arches are digitally manipulated, and each phase of the smile correction is planned. And then, and this is where it gets really interesting, each arch with each adjustment are 3D printed to use as the mold for the resulting aligner. Think about the scale and the complexity of that for a moment. That awe you're feeling right now, that's how we feel every day. Welcome to the team. So now that you're on staff, I want to share with you how we see additive manufacturing and why so many of our clients are interested in exploring the possibilities additive manufacturing has to offer. First, increased complexity and finely tuned results. The materials are extremely varied, and this means that there are many material options depending on the fidelity that you need. When you combine high-end, high-definition materials with computer-aided design, the result is an extremely detailed object, which may have only been achieved through injection molding previously. Even better, 3D printing gives you the ability to tune the result, to perhaps improve performance or well-being, as can be imagined when we look at Adidas's Futurecraft 3D. Their 3D printed midsole allows Adidas to evaluate the individual runner's arch, or it may be impact or other factors, and then design and fabricate a midsole which supports or responds to that runner's specific needs. This brings us to our next element, on-demand printing. The speed and efficiency of additive manufacturing enables companies to print on demand, to rapidly prototype and iterate, saving them significant time and investment. Which brings us to our third point, zero waste. If you're only printing exactly what you need and utilizing on-demand printing to print only when you need it, the waste traditionally associated with other manufacturing methodologies, injection molding for example, are eradicated. Taking that one step further, the amount of dead stock resulting from outdated inventory is also eliminated because you don't need to predict demand and order inventory to hold in hopes that your predictions were right. So what are some areas we expect to see growth and adoption of additive manufacturing? Well, the aerospace and medical industries are investing significantly in their field. In aerospace, Bell Helicopter leverages this technology to quickly and easily iterate their new designs, allowing them to change and update their designs without the typical challenges of updating molds or creating new tools and the expenses associated with iterative design. In the medical industry, they're targeting nanoscale medicine and even complex printed organs. But in the meantime, remarkable work is still being done. In a recent case, Oxford Performance Materials, or OPM for short, developed a cranial implant for a patient missing a significant portion of their cranial bone. Using 3D printing, OPM created a customized, patient-specific cranial implant that was an exact fit. This means shorter surgery and shorter recovery time with a lower risk of infection for the patient. The future of additive manufacturing is bright, but not without its challenges. To achieve its fullest potential, manufacturers and engineers will need to shift their thinking and their processes. Historically, production capabilities determine the ultimate design of a product, But in order to fully realize the potential of additive manufacturing, we must learn to think design first.